Ydse experiment order. Ydse is known as what beta? Young's double slit experiment. Young's double slit experiment. So what is the basic setup of this experiment beta? We are having one parent source. From this parent source, a light was being going, which was being kept in front of there was a cardboard, and the two small pinholes were being made, which were at a distance of d each other. So S1 and S2 are your two coherent sources. The distance between them is equals to your d. So when a light was going from your S1 like this, another light from this one like this, they started bending somewhere here, and this light started bending right now as a form of wave and has been reached to the point B. In the same way, one more wave from this wave has been started going like this and has been met at your point P. So point P now, when the two waves are being meeting, I don't know whether it is a dark or bright. I need to write the condition for both of them. I need to write the condition for both of them. So what I'm telling you that when the wave from the S1 is being moving and it is being meeting it somewhere at a point P, the same time a wave from the S2 is also starting to move and it is reaching at a point of your P after a certain interval of a time. That means there is a certain time lag, and also there is a certain phase difference between them. There is a certain phase difference both of them are starting at the same point beta, but the distance traveled by your S1, the wave from the S1 is lesser compared to S2. So obviously from the diagram you are able to see that S2P is greater than of your S1P. S2P is greater than of your S1P part of relation. Is that clear for everyone? This is a basic setup of your Ydse experiment set in the under key. So the wave which is going from S1 to P and S2 to P, which is greater beta? S2P is greater than S1P. S2P is greater than of your S2. Like that, some millions of the rays are being going from S1 and S2. So there are points on the screen which is undergoing to be either constructive or destructive. But whenever we are taking monochromatic ray of light beta, away from this one, when it is been touching at a point of center, the distance between S1P and S2P will be same. So the central point will always give me the central maxima. So that is the reason I have drawn here thick red color here right now, which is known as of your central maxima. Followed by the central maxima, immediately first arc will be formed above and below the central maxima beta. Okay, whatever is above this one, how many number of maxima ikkada kuda ante maxima, including the central maxima. If above is 4, below is 4, central is 1. So total number of maxima will become how much for me beta? 4 plus 4 plus central maxima 1. So that will become for me your 9. Is it clear? See the diagram beta. If there is any doubt in the diagram, you please let me know. Any doubt in the diagram? I'm taking one more wave from the center of this slits beta. S1 and S2 nunchi center nunchi I have taken a line, dotted line, which is making an angle of theta. Now see the distance from S1 to this center O. So A to O is d by 2 and O to B is also d by 2, because the distance between S1 and S2 is how much beta? D. The distance between S1 and S2 is d. So the distance between A and B is exactly the d. That means the distance from A to O is d by 2 and the distance from O to B is also d by 2. Now say for example, if I am saying that a point P is the distance of Y from the central maximum. I don't know the point P is maxima or minima beta. I need to write the conditions for both of them. If the P is maxima, what is that a Y value? If P is minima, then what is the value of your Y? So I am taking some point P, it may be maxima or minima, which is the distance of Y from the central maximum. Now see this triangle beta from this center. Say for example, if this is O, this is also I'm taking it as of your O, P. So this part of a triangle, if I'm taking right now, this part of a triangle. Okay. So tan theta, how do you write beta? The distance between the screen and the slit is equals to capital D. The distance between the screen and the slit is capital D. So this one is D, this one is Y. So tan theta will be equal to how much beta? Tan theta will be equal to your, can anyone tell me what is the value of a tan theta beta? Tan theta value will be equal to how much? Y by D, this Y, this by D, isn't it? So that is your tan theta. Is that clear for everyone? Is that clear for everyone? Okay.
Sure.
Now this distance S1 and S2. This distance S1 and S2 is how much distance beta? D. That means if I'm taking this distance as of your D, this is your S2 and this one is S1. And this is your distance D. You resolve this distance d into components beta, because a ray of light even from this one is going like this. So this is making an angle theta. What I'm doing, I'm drawing a perpendicular from your S1 onto your S2P. So this is making an angle of here how much for me? 90 degrees. Okay, say for example, this one is say for example N and S1 and N is nothing but what? Perpendicular. It is making angle theta with your slit. So this is your N. If I resolve this d part into the components beta right now, so this d will become here for me d into cos theta, and this will become for me d into your sin theta. Okay, so S1 to N will be d sin theta, and this distance, whatever I'm taking this one. So this is your x. This x is parallel to this d sin theta, so this x will be equal to d sin theta. X will be equal to d sin theta. So I'm writing here right now. See, x is equals to d into sin theta. As theta is very small, so sin theta can be approximated to tan theta. So x will be equal to d into tan theta. So tan theta from the figure, if I'm writing better from this part of a triangle, tan theta will be equal to how much beta? Y by d. So that is equals to y by d. So x is equals to d into y by d. So from this one, I can calculate the value of your y. So y is equals to your x into capital D divided by your small d particulation. Okay, so that was the basic understanding of your YDSC experiment. So what are there in the YDSC experiment beta? We are having a parent source. We are having a parent source right now in this one, which is nothing but equal to your S, isn't it? And in front of that one, we are keeping a cardboard, which are called which are with the pinholes in that one, which are having the which will be acting as of your sources S1 and S2. The waves from the S1 will be going, and as well as of S2. Somewhere at a point P, the two waves which have been interfering may be a constructive or destructive interference. And from S2P and S1P, S2P is greater than S1P. So if I'm dropping a perpendicular on your S2P from S1P, this S2 and N will be equal to your X particulation. And distance between S1 and S2 is nothing but D. If I'm resolving the D into components, I'm getting here D sin theta, and this one has D cos theta. So D sin theta is equals to your X. Okay, and see how we are getting the maxima beta. Central part is always central maxima, immediately followed by first dark, then again the first bright. So I don't know what is the distance between the first bright and the central maxima, first dark and the central maxima. Let us try to calculate that one. Consider that we have got two coherent sources of lights S1 and S2 beta, which have been placed at distance D, and the screen is placed at distance of capital D. Is the statement clear? We are considering two coherent sources S1 and S2, which are being placed at distance of your D, and the screen is being placed at distance of capital D. So let P be the point. This P is nothing but equal to your some point on the screen at a distance y from the point O, exactly opposite to the center of your two sources, that is S1 to your S2. Okay. So which is a distance of y from white beta from the point O, and point O is exactly opposite to the central of your two sources. That means this O is exactly half of your S1, that is AO, and as well as of your OB. A to O is D by 2, O to B is also D by 2. So total distance between A and B will be equal to your S1 and S2, that is nothing but equal to your D. If x is the path difference between the light waves reaching into point P from S1 and S2, that means like say the wave which is going from S to P, it is traveling an extra distance of x. This extra distance we are calling it as of your path difference beta x. So how do you calculate that x beta? X S2P minus S1P because the higher value minus lower value. So that value we have written right now here. X is equals to S2P minus S1P. Is the statement clear for everyone? The path difference x ఎలా వచ్చింది అర్థమైంది కదా అందరికి? S2P minus of your S1P. Now in the right angle triangle S2BP, S2 and BP, S2 and B and P. So this is your right angle triangle one, which is BP. Sorry, not O. S2, this one, and this one. So from this triangle, the distance between P to B is how much beta? Y plus D by 2. And this distance is equals to D. And S2P is nothing but hypotenuse. Okay. Now see from S2BP, what I can write here? The right angle triangle S2BP, we can write S2B whole square is equals to S2B whole square plus BP whole square. S2B is the distance between the screen and slit, that is capital D whole square. BP is Y plus D by 2 whole square. Also in the right angle triangle S1AP, this one children. S1, this one A and P. This distance will be equal to how much beta? From here to here it is Y, this is D by 2. So this will become for me Y minus D by 2. This distance is capital D. So S1B I can calculate right now. S1P whole square is equals to S1A whole square plus AP whole square. So S1P whole square is equals to S1 to A is capital D, A to P is Y minus D by 2 whole square. So it is S2P whole square minus of your S1P square is equals to your how much beta? You know the value right now. So I got the value of your right now S1P. I got the value of your S1P right now in this one. So I got the value of your S1P whole square. I got the value of your S2P whole square. So now S2P whole square minus S1P whole square. Just do the subtraction of that one. So it is D square plus Y plus D by 2 whole square minus D square plus Y minus D by 2 whole square. This D and this D will get cancelled. So it is a form of A square minus B square. So I can write that one as S2P plus S1P into S2P minus S1P. That is equals to Y plus D by 2 whole square minus Y minus D by 2 whole square. If I simplify this one right now, I'll be writing here right now S2P plus S1P. S2P minus S1P is what beta X. So I've written in the place of this one as of your X. Okay, so that is equals to 4Y into D by 2. That means that is 2YD. So path difference, how much I'm getting right now? X is equals to 2Y into small d divided by S2P plus S1P. So that is your path difference. Okay, so X is equals to how much for me? 2Y into small d divided by S2P plus S1P. But in practice, the point P is very, very close to the central screen bed. Okay, that means theta is lesser than like 1 degree and 2 degree, approximately a value ఉంటుంది. So that is the reason S2P is almost all equal to your S1P if I am taking as a capital D. So X is equals to 2Y into capital D divided by D plus D. So 2 and 2 will get cancelled. So X is equals to Y into small d divided by capital D. Is that clear? So path difference formula is how much better right now? X is equals to Y into small d divided by capital D. So Y is the point of maxima or minima on the screen beta and the D is the distance between the slits. So that is a path difference formula. ఈ డెరివేషన్ మొత్తం వద్దు అనుకున్నా కూడా మనం డైరెక్ట్ గా ఒక లైన్ లైన్ ఇక్కడే రాసుకోవచ్చు. వాట్ ఐ డిడ్ ఇస్ ఈ d ని మనం రిజాల్వ్ చేసుకుంటే చూడండి దిస్ ఇస్ ద డిస్టెన్స్ d దీన్ని d ని రిజాల్వ్ చేసుకుంటే దిస్ ఇస్ d sin theta, this is d cos theta. ఈ x కి these two are parallel కాబట్టి in vectors we can equate them. So x is equal to how much I am getting? D sin theta. So as theta is very small, so sin theta is approximately to tan theta. So x is equals to d into tan theta or x is equals to d into y by your capital D. That is the path difference formula. Is it clear the path difference formula beta? X is equals to d into tan theta when theta is very small. When theta is larger, you can't use the d sin theta formula beta. Make sure of that one. When angle is 30 degrees or maybe 60 degrees, at that time you need to use the formula x is equals to d into sin theta. If the angle is very small, like 1 degree, 2 degree, 3 degree or lesser than 5 to 10 degrees, then we can use the formula x is equals to d into your tan theta part equation. Is it clear? So when to take x is equal to d sin theta and when to take x is equal to d into tan theta beta? When x is equal to d sin theta is when theta is very larger. If theta is very small, then we can take the formula as x is equal to d into tan theta. Now we are doing this experiment considering theta to be very, very small. So that is the reason I got the path difference as of here. How much for me? X is equals to y into small d capital by capital D. What is small d? Small d is the distance between the slits and x is nothing but of your path distance and capital D is nothing but what? Distance between the screen and as well as of your slit. Okay. Now for maxima, what is the path difference? But can anyone tell me? I'll tell you. Maximum is what? Constructive interference. For constructive interference, yes, path difference. For constructive interference, what is the path difference we got? Delta x is equals to n lambda. And for the destructive interference, the path difference is how much for me better? Delta x is equals to lambda by 2 or 2n minus 1, provided n is equals to 1. If I start n is equals to 2, then you can take this one as 2n plus of your 1 also. No problem in that one. Is that clear? Path difference delta x is equals to your n lambda for the constructive interference and path difference delta x is equals to lambda by 2 for the 2n minus 1 for your destructive interference. That means for dark point and bright point. For bright point, what is the path difference we'll be taking always? N lambda. And for the dark points, we'll be taking 2n minus 1 lambda by 2 or 2n plus 1 lambda by 2. That depends upon our understanding. Okay, sure. See this one. For maximum, we know that x is equals to how much better? N into lambda. So now in the place of x, you substitute n lambda. So y is equals to n into lambda into capital D divided by small d. So for nth bright point, taking n is equals to 0, 1, 2, 3, I can calculate where the nth bright point has been formed. Where is the first bright point is forming? If I take n is equals to 0 in this equation, n is equals to 0, y1 is equals to 0. That means at central maxima. At central maxima. y1 0 in the diagram. If y1, this y is becoming for me 0, that means at O, the central maxima has been formed. Then if I take n is equals to 1, then d lambda by 2, that is first bright point. and n is equals to 2, y3 is equals to 2 lambda into capital D divided by D. That is the second point. Like that, it will be going on forming. Now for minima, x is equal to how much for me better? 2n plus 1 lambda by 2 or 2n minus 1 lambda by 2. If I'm taking 2n plus 1 lambda by 2, then we'll start n is equals to 0. If I'm taking x is equals to 2n minus 1, then we'll start from x, n is equals to 1. So x is equals to how much already for the path difference we got? Y into small d divided by capital D. So nth dark point has been calculated by the formula 2n plus 1 into lambda into capital D divided by 2d. n is equals to 0. We are getting as lambda into capital D by 2d. First dark point. And half of the first maxima ikkada undi manaku lambda by 2. So that is nothing but lambda into d by 2. Then student half lo vachindi. That means in between central maxima and the first maxima, the first dark has been formed. The same way, if I'm taking n is equals to 1, then 3 by 2 lambda into capital D by small d. That is second dark. N is equals to 2, then we are getting the third dark like that. Is that clear for everyone? Is it clear for everyone?
Yes, sir. Yes, sir.
So చూసుకున్నాను path difference ఎంత వచ్చింది path difference formula important and in the Ydse when the wave is going from s1 to p and s2 to p the path difference is calculated with the formula x is equals to d into sin theta. If theta is very large you will use sin theta, if theta is very small then you will be using tan theta. Is that point clear for everyone? I have derived how I got that path difference x is equals to d into y by d mathematically and by the geometrical method also. Geometrical method is very easy to understand for competitive examinations provided you are just talking about completed, but when you go for the derivation of your board exams or something like this, this is the way how do we derive the derivation for that one to get the path difference of this one. You can just check this derivation once again. So path difference, how much I am getting? 2y into small d divided by s2p plus s1p. In practice, the point p is very, very close. This point p. This point p is very close, somewhere basically. So as it is very, very close to that one, so angle is right now for me how much? Almost all same. That means s2p will be equal to your s1p. Okay, so that is the reason s2p is equal to s1p and that is equal to how much for me? Capital D. So if I'm taking the two values to be d and simplifying, we are getting the path difference formula as x is equals to y into small d divided by capital D. Clear? So for maxima, we are getting x is equals to n lambda and simplify the values of that one. And for minima, you use x is equals to 2n plus 1 in the place of your x and simplify the formula. So we got a general formula for your nth bright and nth dark point part of which. Clear? These two formulas are important, beta. These two formulas are only very important for the competitive examination. Is it clear for everyone? దీంట్లో ఏమైనా డౌట్ ఉంటే అడగండి. Clear, beta? Any doubt in this one? So what type of light we are using beta here? Monochromatic wave of light. Monochromatic means one single wavelength. One single wavelength. I've sent you one video. Have you seen that one beta? Ydse experiment in the light. Sunlight gonna get how do we get it out? I've sent it to you, Sivitas. Just try to go through that video once. I'll show it here also. Check your WhatsApp group at once.
Yes, sir.
Yes, sir.
He was doing the experiment in the white light. That means in the sunlight. See what is the pattern he got at a time. Very good experiment. Are you able to listen me better?
No, sir.
No, sir.
I hope you got it, that point better. Is it clear for everyone? So what is happening is, if the two of the waves are be interfering, so we may be getting a constructive interference or your destructive interference. Okay. So how do you calculate that constructive and destructive interference is by the help of the basic formula. If it is the y is a bright point, then bright point is calculated by the formula y is equal to n into lambda divided by lambda into capital D divided by small d. And what type of a light we are using here, beta? A monochromatic source of light. But the experiment what you have seen is right now white light. Now the question is right now arising, what happens if white light is being used? I'll tell you, see that. Don't try to write it out better. Yes, beta. Someone is raising the hand. Any doubt to anyone? Now we are trying to do the YDSC with not monochromatic light of light beta, but with your white light. Then what happens? Let us try to see what happens here, right? Now the question is, what will happen if we use white light? in YDS? That is a basic question. Okay. So what happens if a white light is used in the YDSC experiment? Just now you've seen the experiment. So what you might be getting the answer at the central point, we'll be getting the white color. Next followed by the red, then next followed by the bluish. Then the colors go on take like that. Okay. So if we use the white light instead of monochromatic light beta, what exactly is happening is right now for me, central white bright fringe with reddish white fringes followed by the bluish white fringes have been followed. Okay. So at center we get white bright spot followed by reddish white, then followed by bluish. Okay, that means if I'm taking an experiment like this, and there is a cardboard in front of this one. This is your S1 and this is your S2. And this is your central maxima. That is a distance of capital D. So what is happening is your white light from this one, the red light is coming like this. And in the central part, we are getting a red color. The next one is nothing but of your central part we are getting right now for me what beta? White point, sorry. I can write this one as white point. And it is being followed by your red color. Just above it. And below is also your red color. Okay. Then it is being followed by your blue color. Like this. Okay, like this the colors goes on forms right now. So at central part what we are getting? White point. Red color means it is a combination of everything beta. Delta x is equals to 0. Then above it you are getting your red. This one is also your red. The next one is nothing but of your blue. The next one is also your blue, like this. Clear? Is it clear? Question is what happens if a white light is being used in the YDSC? At a central point, we'll be getting the white color. It is a combination of all the colors in the white. That means red color, violet color, everything. Delta x is equal to 0. Above and below, we are getting right now for me a reddish white violet color or reddish dark violet color in the downward direction. And the red dark bluish in the above. Like that, small variation currents will be formed in the given condition. Is it clear for everyone? Is it clear for everyone? Is it clear, beta? Am I audible to everyone?
Yes, sir.
So I hope you got an idea what happens if you are using a white color light instead of a monochromatic ray of light. If you are using a monochromatic ray of light, we are getting at a central one maxima point. Whereas here in the different colors when you are using, the central part is always a white, followed by the reddish violet, then followed by your bluish violet, go on like that one, different colors will be formed in the form of your rainbow part of relation. I hope you are clear with this one, everyone. Any doubt in this one to anyone? ఎవరికైనా డౌట్ ఉందా దీంట్లో? Is it clear for everyone?
Yes, sir.
Yes, sir.
Make one small note here, beta. Intensity is directly proportional to width of slit. అంతే కదా ఒకవేళ హోల్ పెరిగింది అనుకోండి intensity of light is also increasing. So intensity is also directly proportional to your width of the slit. That means I can write here I1 by your I2 is also equal to your width W1 divided by W2. And intensity is also directly proportional to what, beta? Square of amplitude. That is nothing but of your A1 square divided by your A2 square. Intensity is directly proportional to the width, and that is directly proportional to your amplitude part of it. Clear for everyone? How intensity is directly proportional to width, beta? ఎందుకంటే ఈ hole size పెరిగింది అనుకోండి, light rays coming from the holes will be increasing. So if the number of ray of lights coming from S1 is increasing, that means the intensity is also increasing part of it. Is that clear for everyone? Is that clear?
Yes, sir.
I'll give you a rough question right now on this one. Take one small question. If I say that if I minima divided by your I maxima is equals to 9 by 5, then W1 by W2 is equals to how much? Okay, we know I max and I minima formula already from the constructive and destructive interference beta. What is that? So it is I minima divided by your I maxima is equals to root of your I1 minus root of your I2 whole square divided by root of your I1 plus root of your I2 whole square. Isn't it? So I minima by I maxima is given how much for me? 3. So squaring on both the sides, I can write this one as I minima divided by your I max whole square is equals to root of your I1 minus root of your I2 divided by root of your I1 plus root of your I2. Isn't it? Is that clear? Is that clear? Square ఉండదు కదా తీసేస్తున్నాం అంతేనా? See here, what exactly I was trying to write is I minima by I maxima. I can write directly the value beta. This is square here as it is. I minima by I maxima is given how much for me? 9 by 5. 9 by 5 means I can write this one as 3 by 5 whole square. This one and this one will get cancelled here. So 3 by 5 will be equal to your root of your I1 minus root of your I2 divided by root of your I1 plus root of your I2. Now cross multiply this one. So this one is a 3 into this one is root of your I1 plus root of your I2 is equals to 5 into root of your I1 minus of root of your I2. That means 3 into root I1 plus 3 into root of your I2 is equals to 5 into root I1 minus 5 into root of your I2. Okay. So all the I2 terms we take on one side and I1 terms we take on one side. Root 3 I1 and this one is 3. So 5 minus 3 that will become for me. So it is 2 times of root I1 is equals to this will become for me how much better? 5, 6, 7, 8. So it is 8 times of your root of your 8. Isn't it? So this one will become how much for me? 2 1s are 2 4s are. Isn't it? That means I can write here root of your I1 divided by root of your I2 is equals to 4. Okay. That means I1 divided by your I2 will be equal to how much? 16. So I can write here width right now, beta. W1 divided by W2 is equals to your I1 divided by I2. So that will be equal to 16. So width of this one will be equal to 16:1. Is that clear? Is that clear?
Yes, sir.
Sure. How do you calculate number of maximas or bright fringes? Number of maximas or bright fringes. Okay. Now, what do you mean by bright fringes? Better, let me talk about first fringes right now here. Fringe width and included. See here, fringe width with angular and angular position better. The separation between two consecutive bright and consecutive dark fringes. Fringes means this one, the slit which has been forming, is called as of your bright fringes or bright points. The separation between two consecutive bright point or the distance between two consecutive dark point. Like this is one bright point and this is one bright point. So distance between these two bright points is known as of a fringe width represented by beta. Okay, or the distance between two dark points. See here, I have taken two dark points here, one dark point and here one dark point. So the distance between two consecutive bright point or two consecutive dark points is called as a fringe width and it is represented by beta. Beta is the distance between two consecutive bright fringes. Now fringe width of bright point gavan ankondi. If I need the fringe width of a bright point means fringe width will be equal to second bright point minus first bright point cheyala. అంతే కదా second bright point minus a first bright point చేయండి, that will give me the fringe width. So it is a 2d lambda by d minus of d lambda by d. So fringe width, how much I'm getting? Capital D lambda by small d. Or else if I'm taking in terms of your third bright fringe minus second bright fringe, for that one also I'm getting the same. So any two fringes you take consecutive part, we'll be getting the fringe width formula as capital D into lambda divided by small d. The same way fringe width for the dark point, if I'm calculating, for the first dark it will be distance of the second dark minus first dark. First dark in the 3 into capital D lambda by 2d minus this one is capital D lambda by 2d. So simplifying it again, I'm getting capital D into your lambda. So we know for the nth dark, what is the formula better? 2n minus 1 into capital D lambda by 2d, where n is equals to 1, 2, 3, go on. The same way width for the second dark, if I'm calculating, that means the position of the third dark minus second dark. So it is 5d by lambda, 5d into lambda by 2d minus 3d into lambda by 2d. Simplifying it, I'm getting d lambda. So the fringe width of the dark point, if I'm talking about fringe width of a dark point, width of your nth dark point or fringe width of the dark point will be equal to your nth dark minus of your n minus 1 the dark point. So just simplifying that relation better, I'm getting the formula as capital D lambda by small d. So width of your nth dark or nth bright, if I'm taking, the formula is always constant, that is d lambda by small d. Even the form way, if I'm talking about width of your nth bright point, that means nth bright minus n minus 1 bright point. So that we are simplifying it. Again, for this also, I'm getting the same formula, capital D into lambda by small d. And here capital D must be much greater than of your small d. The capital D is in meters, where d small d is nothing but in millimeters. So what is the fringe width formula beta? Fringe width is equals to your beta is equals to capital D lambda by your small d. You do it with the dark point for the bright point, the derivation final result is coming out for me same. So fringe width is nothing but the separation between two consecutive bright point or two consecutive dark point is known as of your fringe width, is known as of your fringe width. Is it clear for everyone? So fringe width is nothing but what? Distance between two consecutive bright points or two consecutive dark points. So I calculated for the dark point and bright point, simplified it, and we got the result. The final formula for the fringe width is capital D into lambda by small d. Now what is an angular fringe width beta? We know the path difference formula, x is equals to d into sine theta. So for the first bright fringe, I can use delta x is equals to n lambda. For the first bright fringe, n is equals to 1. And delta x will be equal to how much for me? Yeah, delta x is nothing but what? X. X is nothing but equal to lambda. So use that formula, d sine theta is equals to lambda. So sine theta is equals to lambda by d. If theta is very small, then only I can write first bright fringe is making an angle of lambda by d. The same way second bright point, x is equals to 2 lambda. That is 2 lambda by d. So like nth bright angular fringe width, you can use the formula for nth bright fringe. Angular fringe width formula is n into lambda by your capital D part of relation. Is that clear for everyone? So this one. So this is your point, central point, and this is your central maxima, isn't it? So this is your first angular fringe width, first bright, and this is your second bright, isn't it? So if I'm taking the difference of that one, that will give me the fringe width. That will give me the fringe width. The theta of your FB is nothing but of your fringe width part of relation. Clear? So we got like that for the bright. Even for the first dark, if I'm taking, path difference is how much better? Delta x is equals to, path difference is equals to lambda by 2. So delta x is d sine theta. So sine theta is lambda. So theta of the first dark will be equal to how much better? So sine theta is equals to this much for the dark. So first dark is equals to, if theta is very small, so it is lambda by 2d. Okay, so for second dark, delta x is equals to how much for me? 3 lambda by d. So like that, if I'm taking like third dark, so nth dark, we are getting the formula 2n minus 1 into lambda by 2d. So angular fringe width is nothing but what, beta? It is angle made by the second dark minus first dark, that is lambda by d. Or if I'm doing for the bright point also, second bright minus first bright, lambda by d. So whether you do for the dark point or for the bright point, the formula is one and the same, that is lambda by d part of relation. Okay, now fringe width formula will become how much, you see? Fringe width is capital D lambda by 2d. So lambda by d is beta by d. So angular fringe width is nothing but lambda by d. So theta can also be written as of your beta by capital D. Okay, if this experiment is done in the water, beta, then wavelength will be changing. So in the liquid, the wavelength will be equal to lambda by mu, because the remaining everything will remain same. Capital D is not changing, small d is also not changing. So when it is in air, fringe width is given by the formula capital D into lambda by small d. When it is in the water, the fringe width will be changing. So that is beta dash is equals to capital D into lambda dash divided by d. Lambda dash is how much for me? Lambda by mu. So beta dash will be equal to beta into air divided by mu. That means it is 1 by mu times of the fringe width in the air when it is being done in the water. Fringe visibility gives the knowledge of coherence beta, fringe constant and interference pattern. That is directly the relation as V is equals to I max minus I minima divided by I max plus I minima. You simplify it, we'll do it this one in the numericals. We'll be getting the formula 2 into root I1 plus I1 into I2 divided by I1 plus I2 part of relation. And in the intensity distribution curve, you see beta, I told you I maxima formula is 4I0 and I minima is 0. That means energy is just becoming maxima, minima, constructive, destructive, destructive to constructive, and there is no loss of your energy. You see, at exactly central, we are getting maximum beta, that is 4I0. Then immediately followed by the first dark, that means intensity is becoming 0. Again, immediately followed by the first bright, that is nothing but 4 times of I0. So it is becoming from dark to bright, bright to dark, dark to bright. So intensity is always found to be the same. So in this one, it has been found that in the interference of wave or in the interference of a light, energy is just getting maxima to minima, minima to maxima. That means interference occurs due to the law of conservation of energy. That is, redistribution of your energy is taking place from maxima to minima and minima to maxima. That is the reason we are getting the graph to be equal. Okay, and I max and I minima, just I told you that intensity is directly proportional to the width, and A1 and A2 are amplitude. So I minima by I max is equals to A1 minus A2 by A1 plus A2 whole square. Or width, if I'm writing, that is root of your W1 minus root of your W2 divided by root of your W1 plus root of W2, because intensity is directly proportional to width. Or else I can directly write that one as root of I1 minus root of I2 divided by root of I1 plus root of your I2. So these are the some of the standard formulas you need to remember. So please try to go through this one beta. Intensity distribution is based upon which law? Means it is just based upon law of conservation of energy, in which energy is becoming from constructive to destructive, destructive to constructive, and there is no loss of your energy in these conditions. So it is just redistributing the energy. That is the reason it is becoming first 4I0, then it is becoming 0, again 4I0, again 0, again 4I0. So when you're doing the experiment, the intensity is always found to be the constant. That is the reason that yellow dotted line I have drawn in the above direction. Okay, so this was some of this one. And fringe visibility direct formula you need to remember beta. Fringe visibility is nothing but ratio of I max minus I minima divided by I max plus I minimum. So if I write that formula and simplify it, we'll be getting this formula. This I'll derive it while doing the numericals part of relation. What happens when Ydse done in the experiment means, if it is this experiment, if it is done in the water, then the distance between slit and screen will always remain same, that is capital D. The distance between S1 and S2 also will remain same, that is small d. But only thing is wavelength will be changing. So that will change in wavelength from the ray optics chapter. We know it. Lambda dash is equals to lambda by your mu. You need to remember this one. This will be coming in the ray optics chapter beta. That is mu is equals to your lambda is wavelength in the vacuum. Lambda dash is the wavelength in the water or in the medium. Okay, so beta dash of air is capital D into lambda by small d, and beta dash will be equal to capital D into lambda dash divided by d. So lambda dash value substitute is simplified. So we'll be getting beta dash is equals to 1 by mu times of beta in the air part of relation. Okay. So and angular fringe width basic formula is theta is equals to lambda by d, and that lambda by d is also equal to your beta by capital D. So this is again very important formula you need to remember. Because all of them are derivations beta only for your understanding, but final results are important, which have been used for doing the numericals part of relation. So angular fringe width for your nth dark, what is the formula, and for the bright fringe, what is the formula? Clear? So nth bright it is n lambda by your d, And for your nth dark also, the formula is 2n minus 1 into lambda by 2. If I'm using 2n minus 1 beta, then with the n should be started from which one beta? N is equals to 1, 2, 3 to start your square. Okay, now? Is it clear, beta?
Yes, sir.